Okay. Let's look at 4.4. This is actually something new for you guys. And we're going to be using it when we talk about algebra, something called the exponent laws. There's 3 of them that we're going to focus on: multiplying, dividing, and then raising one exponent to another exponent. And we're going to talk about multiplying and dividing today. And they're pretty straightforward. Okay. Let's say we wanted to multiply 7 to the 4th times 7 to the 5th. Okay? How do I write 7 to the 4th out? How do I write it out? 7 to the 4th. 7 times 7 times 7 times 7. That's 7 to the 4th. How do I write 7 to the 5th? And I'm asked to multiply these two. So how many 7s are you multiplying by each other? So isn't this the same as 7 to the 9th? Can you see a shortcut to get from here to here without having to do this? What do you do? Like if I told you guys this, if I said, okay, 6 to the 8th times 6 to the 3rd, write that using one power. 6 to the 11th, right? Because you just add the exponents, and the base stays at 6. That's it. That's the multiplication exponent law. So whenever we multiply 2 powers together, or more powers, with the same base, so if I have x to the m, and those represent some numbers, and I multiply that by x, same base, to the n, that's the same as keeping the base the same and adding the 2 exponents.
Wait, where did you get? What?
Where did I get?
What is the end of it?
So these just stand for numbers. That's all. So like imagine above, this would be 7, these would be 7s, this would be 5 and 4.
Okay.
Yes. So that's the multiplication. You just, the base, you write the base, and then you add the exponents to get the answer. What do you think you do for division? If we multiply 2, we add the exponents. If we divide the 2, we subtract the exponents. So look at it this way. 11 to the 10, well, that's 10 11s being multiplied by each other. I got it. Oh, still got that. Here, I think I got 10. Oh, I got too many. Yeah. And then I divide that by 11 to the 4th, or 4 11s multiplied by each other. Well, what I can do is I can cross pairs of 11 from the top and bottom. So I can cross these ones out, because 11 divided 11 is 1. I could divide these ones and cross them out. Same with this. Same with this. So now I'm done, because there's no more 11s in the denominator. So how many 11s am I left with? 6. And remember, mathematicians are lazy. We want to look for a shortcut. We don't want to have to write all this out. Yes, it's exactly what you do. So if you have 1 power, x to the n, divide another power with the same base, you just write the base and subtract the exponents. That's it. That's all you have to do. Yeah.
You don't have to write out where you just do like 10 minus 4.
Exactly. Yeah. Yeah, and you can just do that in your head. So like, for example, here, these two. Notice, okay, you gotta read instructions carefully now. Notice the difference in instructions here. You don't find the answer. You don't find the value. All you're asked to do is write this using one power and one exponent. 6 of them, because we add the exponents. You're asked to divide these two. Yes, base stays exactly the same. Keep the parentheses. -9 to the 4. Yeah. Now here, you're asked to find, it says evaluate. So what we want to do is we want to simplify as much as possible, and then we want to evaluate, meaning we want to find the answer. So how can I write this using one power? Yeah, what's the base? -2 in parentheses to the 11th. Because we add the exponents. Right? And now, do that on your calculator.
I think it's 11,000.
Lots of different negatives.
No, negative.
Negative
11,600.
11,600. Anybody else get that, just to confirm? Anybody else want to do it, just to confirm that we've got it right? You should be practicing it on your calculator anyway, just so you know how to do it. So open parentheses and then the negative sign. Okay,
I got 2,000.
2048, -2048. Good. Yeah. Now look at this one. We're timesing the first two, which means what do we do with the exponents? So this is the same as 3 to the 6th. But I still have to divide 3 to the 3rd. Right? So I just did this. Well, I can use another exponent law, the division one. What's an easier way to say this? 3 to the 3, because that's subtract. And then 3 times 3 times 3.
Do you go on like order?
Yes, left to right. If it's all multiplication and division, you just do left to right. If it was addition and subtraction thrown in there, you do those later. Yeah. Cindy? Yeah. Thank you. So yeah, so Finley, what you were asking about, here's an example. Notice I'm doing some adding and some multiplying. According to order of operations, what do I do first? I have to do these two. So I'm not touching the 6 squared plus. But what's an easier way to write this? 6 to the 5th. Isn't that what you said?
Yeah.
Yeah. Yeah, that's fine. Okay, now this we can't do. You can't make this 6 to the 7th. Why? Because it's not multiplication. So all I can do now is pull out my calculator, do that, and add them. So this is 36. Ooh, 6 to the 5th.
Whoa.
216 times 6, 12, 96 times 6, 7,000.
Yeah, $7,776.
76. And then we still have to add the 36.
7,812.
7,812. Correct. Okay, this last one's a little crazy. Because we got a bunch of exponents with -10 as bases. What are you going to do first? The division, what's in the brackets. So I'm not, notice how I write my steps, which most of you are doing. I just rewrite what I'm not touching yet. The only thing that I'm doing is inside the brackets, pardon me. What do I get when I divide these two? Right. And then I write -10 to the 7 because I haven't done it. What am I going to do next? The multiplication. And what do I get when I do this? -10 to the 6. -10 to the 7. There's no more exponent laws to do. I can't remember, there's no subtraction exponent law. We only subtract as if we're dividing. So I got to do this on my calculator. Or if you remember your powers of 10, isn't this going to be positive because I'm multiplying 6 times? And isn't it going to be a 1 with how many zeros? So this is going to be 1 million. And it's going to be positive because 6 negatives multiplied by each other is positive. And this is going to be 1 and 7 zeros. And what is a million minus 10 million? Positive or negative? Negative, right? Because we're subtracting more. -9 million. Okay. So those are 2 of the 3. We've only got 1 more left to do. And we'll do that. We'll do that when